Hi, I'm Brandon Graysley. I'm a high school math teacher. We're going to look at what similar and congruent triangles mean today. And we use these two symbols. This looks like a squiggly equal sign, and this looks like a half squiggly equal sign for congruent triangles. Similar triangles, if you have two triangles that are similar, all of their angles are the same. If you have two triangles that are congruent, everything's the same, their angles and their sides. So I'll show you two similar triangles. Let me show you this one here first. There's my first triangle, A, B, C, and then I'm going to show you one that's really similar to it. Alright, see that? I'm going to put a couple more labels on there, D and E. And so my first triangle, the outer triangle, A, B, C, is similar to the one inside here, D, E, C. D, E, C. Now it's really important that you understand that this corner here, this A and this D bit there, those are the same angle, and that B and E, those are the same angle. They correspond to each other. And of course, C and C are the same angle. They correspond to each other. You got to get the letters in the right order, because sometimes you'll have two triangles like this. You know, one maybe looks this way, A, B, C, and another one is similar but kind of points in a different direction or is flipped over or something. Maybe you've got something like this here, D, E, F, and you got to line them up and get them coordinated here. So this one here, the F and the B must be the same. So triangle something or other is similar to triangle something or other. Well, I know that B and F correspond to each other. That part's easy. Now C has to be this point here, E, on the other side. So C is related to, or corresponds to E, and then that leaves me with A and D. A and D. So you got to line them up so that the first vertex here is the same angle as the first vertex here, and so on throughout the rest of the triangles. So that's the similar triangles. The congruent triangles are a little less interesting. That just means they're exactly the same. So I have two triangles like this and this. I didn't draw them very well, but those are exactly the same. So if I have A, B, C, and D, E, F, I say that triangle A, B, C is, it looks like an equal sign with a top squiggle, congruent to triangle D, E, F. And once again, you got to get the angles in the right order. Sometimes when you draw a picture, it's not clear that things are congruent, so you describe it with a little bit of math like that to say these things are congruent even though my picture is kind of terrible. So how do we use this then? Well, we use it when we know some things about one triangle and we know this kind of relationship, this kind or this kind, and we want to apply those same things to the other triangle. So for example, let's say I have a triangle like this one, and I know that this, let's call this, I don't know, how about ABC? I know some things like this is 4, and this is 3. That makes this an isosceles triangle. And I have another triangle which I draw over here with a terrible diagram, and it looks like this. I draw it in there like that. Very, very bad diagram, but I also say this is an isosceles triangle. 2 tick marks this time because it can't be the same as my, it's not the same length as these. And let's call this one DEF. And I know this length here is 8, and I know that triangle ABC is similar to triangle, let's get the order right, A and D have to be the same, D, and then E and F. Alright, so that means that this one would kind of like fit inside of this triangle, sort of like this here, up in that space. So we get this interesting relationship though, is that if you take the ratio or divide together any two sides that correspond to each other, so like BC corresponds to EF, then that same relationship, that same fraction that you get is the same for all of the other pairs of sides. So for example, BC divided by f, those lengths, 3 divided by 8, is equal to AC divided by DF. Okay, so let's fill in some numbers here. BC is 3, EF is 8, AC we know is 4, and so DF is the thing that we don't really know yet. So let's do a little magic here. DF is going to be 4 times 8 over 3. Oh, I'm running out of space here. Let me move up. So 4 times 8 is 32 divided by 3. That's a beautiful fraction. We'll just leave it as a fraction. If you really wanted to go into a mixed number, you could do 10 and 2/3. So we can use that, the fact that they're similar, to set up this relationship here, which gives us an equation to solve for one of the missing sides. And since they're both the same, this other side is also 32 over 3. So that is similar and congruent triangles. Similar means the angles are all the same. With congruent triangles, the angles and the sides are all the same. I hope that helps, and ask me some questions. Thanks.